Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Esra Soraya Binti Mazlan, and today we'll be learning on hypothesis testing involving two population mean. As you already know, there are three cases, but today we'll be focusing on case 3, which is for unequal variance. So let's look at question first. Below are the sample statistics for stopping distance of winter and alpine tires. Assume that the population are normally distributed and the population variance are not equal. Test to see if there are differences between the mean of these two types of tires. Use 0.05 level of significance. Given is the table for winter tire and alpine tire. For winter, the sample size is 10, standard deviation is 10 feet, and the mean is 102 feet. Whereas for alpine tires, the sample size given is 12, standard deviation is 4 feet, and the means given is 94 feet. So, how do we know that this question actually refer to case 3? Okay, as you can see, the data given does not give variance value. So, it is unknown variance. If the variance is unknown, there are two possibilities, which is case 2 and case 3. However, this question refers to case 3 because of the sentence, the population variance are not equal, which we assume. Okay, so as you can see, the variance is unknown and we already assume that the population variance are not equal. So, it is case 3. And in order to solve this type of question, you need to do 5 steps, which is, first is set up your hypothesis. Second is do statistical test. Third one is find the critical value. The fourth one is take the decision rule and make decision. Lastly, do the conclusion. Okay? Now, let's look at first step. Set up hypothesis, which is H now is mu1 equal to mu2. H1 is mu1 unequal to mu2. Okay. And how do we know that what this question actually claims? Look at the question back. Test to see if there are differences between the mean of these two types of tires, which mean unequal. Differences mean unequal. So we claim at hypothesis alternative, which is mu1 is not equal to mu2. Next is the statistical test. First, we need to look at the size sample. Okay, the sample size. If the sample size is lower than 30, we need to do t-test. However, if the sample size is 30 and above, we need to do z-test. So, what is the difference between these two types of sample? The differences is z-test and t-test is what you need to refer, which is the table. If the sample size is lower than 30, you need to do t-test, which will be, we need to refer next on t-table. Whereas for sample size 30 and above, we need to refer to z-table. Okay? The formula is the same, so you don't need to worry. As the differences is what table you need to refer only. Okay. The formula is x1 bar minus x2 bar minus, in bracket, mu1 minus mu2 over square root of standard deviation 1 power of 2 over sample 1 plus standard deviation 2 over 2 over power of 2 over sample 2. Okay. Now we just need to substitute the data given into the formula. Okay. X bar 1 is 102 minus x bar 2 is 94. 94. Okay, minus mu1 minus mu2. You can look at the hypothesis, or also if it's stated in the question. If there is no mu stated in the question, we just need to write it as 0. Okay, 0. Okay, standard deviation 1 is 10 power of 2 over sample size 10 plus 4 2 over 12. Okay, now we just need to use our calculator to find the answer. The answer is 2.376. Okay, for the t-test we get 2.376. Next we need to find the critical value. Okay, alpha given is use 0.05 level of significance, so alpha is 0.05. Okay, next we need to find v, or also known as degree of freedom. The formula given is standard deviation 1 square over sample size 1 plus standard deviation 2 square over sample size 2. Bracket square over with standard deviation 1 square over sample size 1 bracket square over sample size 1 minus 1 plus in bracket standard deviation 2 square over sample size 2 close bracket square over sample size 2 minus 1. Okay, so now we also need to just substitute into the formula. Okay, standard deviation 1 10 square over 10. Sorry if my writing. Okay, next is 4 square over 12 and square here. Okay, and then standard deviation 1 again, 10 square over 10 close bracket square 10 minus 1 plus this one is 4 square over 12. Okay, and 2 12 minus 1. So after you substitute, just need to use calculator in order to find the answer again. The answer we get will be 11.3943. However, we convert it to decimal places, it will be 11. Okay, so our degree of freedom is 11 and our alpha is 0.05. Now let's put it inside in order to find the critical value. T alpha over 2 square comma v. Okay, why alpha over 2? Because this is two tail. Okay, which is alpha 1 doesn't equal to alpha 2, 2 tail. So alpha over 2. So T 0.05 over 2. Our V is 11. Okay. So 0.05 divided by 2 is 0.025. Okay, 11. Now, after we find this, we just need to refer to T table, okay? Okay, as you can see, the T table is 0.025. Here, alpha is 0.025. And for the V is 11, which is, we get, our critical value is 2.201, okay? 2.201. This is our critical value. Now, the decision rule is reject H null if our t-test is bigger than t critical value. So, we make the decision is, since t-test, we write back what is the value of our t-test is 376. Okay, 376, sorry. And our T critical value is 2.201. 2.201. As you can see, 2.376 is bigger than 2.201. So, which means our t-test is bigger than our critical value. Hence, we reject or fail to reject. Let's look at the decision rule. Will we reject H null if our t-test is bigger than t critical value? So, if our t-test is bigger than our critical value, we will reject, right? We reject H null. So, lastly, the last step is write a conclusion. Add, okay, look back, 5%. Level of significance. We can, because we already reject H null and we claim at H alternative. So, we can conclude that there are differences between the mean of these two types. That's all. It's simple to do this type of question, right? So, I hope this question will help you in order to solve the hypothesis test which involve two population mean for case 3. Thank you.